Something weird happens when you add up the first n odd numbers. Let's take a look. Can you see it yet? When we put in the first n odd numbers, out pops the nth square. But why? Let's take a different approach to see what's happening. We can represent numbers using dots. Then 1, the first odd number, and the first square looks like this. Now, let's see what happens when we add the second odd number, 3. As you can see, out comes the second square, 4. We can continue like this. This approach might seem a bit arbitrary, but let's put it into perspective using the general form for an odd number. We can see that each subsequent odd number naturally constitutes an extension of our square, with the 2 k's denoting the new sides of our square, and the 1 representing the dot in the upper right corner. What are the odds that you and I have the exact same birthday? Pretty slim, around 0.27% or 1 in 365. But what if it's not just us? What if we have a mutual friend? Then the likelihood that at least 2 of us share a birthday, or more easily calculated as 1 less the likelihood that none of us share a birthday, is equal to about 0.82%. Bigger, but not by much. But watch what happens to the probabilities as the number of people increases. You can see that as the number of people increases, the likelihood of 2 of them sharing a birthday increases disproportionately. Take a moment to think how wild it is that if you invite just 22 other people to a party, there's a more than 50% chance that at least 2 of you have exactly the same birthday. This has got to be one of the most cursed numbers I've ever seen. Just take a look at this. Okay, so right off the bat, in the center, we can see 666, the infamous number of the beast. But that's not all. Notice that it's 31. That's unlucky number 13 backwards, digits long. And even worse, the number of the beast is surrounded on either side by 13 zeros. If that wasn't enough, the number is a palindrome, which means it's read the same forwards and backwards. And on top of all of that, it's a prime number. Dubbed Belphegor's prime, the title derives from the surname Belphegor of the 7 Princes of Hell, a devil associated with the sin of sloth, and the number itself is symbolized by an upside down pi. If that isn't cursed, I don't know what is. This is the Earth as viewed from above. It has an equatorial diameter of about 12,742 kilometers. That's nearly 13 million meters. Imagine that we tie a rope around its circumference. We'll say that the rope has length L. Now consider extending the rope so that everywhere on the Earth's equator, the rope is now 1 meter from the surface. The question is, how much would we have to lengthen our rope by in order to make the change, assuming that the equator is a smooth circle and our rope is more or less perfectly thin? Feel free to pause the video and have a think about the problem and take a guess. So was your answer about 6 meters? Seems pretty crazy, right? To begin, recall that the circumference of a circle and length of our rope, thanks to our assumptions, is given by 2 pi times its radius. Then consider what's really going on when we extend the rope. We're just increasing the radius of our circle by 1. Then, expanding after our transformation, we find that we have our initial circumference of length 2 pi r, plus an additional 2 pi. That is roughly 6.3 meters. And the coolest part about all of this is we always extend the rope by the same amount, whether it's tied around a tennis ball or an entire planet. Start with a circle. Inscribe 2 points A and C such that the line connecting them is the diameter of our circle. Inscribe an additional point B and consider the triangle created by the 3 points. The question is, what is angle ABC? First, we know that our triangle has internal angles summing up to 180. Next, bisect our triangle, drawing a line from B to the circle's center, creating 2 isosceles triangles. We know that the angles on the edges of the circle are equivalent inside both triangles. Equating the known and unknown values, we can find an expression for angles alpha plus beta, in turn giving us angle ABC, which must be a right angle.